Hello, my name is Abigail Glover, and this is my Fluent Project 3 for Dr. Ozbay's Fluid Mechanics class for the spring 2023 semester. So as you can see, I already have my workbench pulled up. I'm just going to click and drag over Fluid Flow Fluent. And I'm going to start off with our first case for this assignment, in which our Reynolds number is less than 1. I'm going to start by right-clicking and opening up Design Modeler. We're going to leave it in 3D for this project. Just going to start by drawing a circle and a rectangle, and then defining the dimensions. So as you can see here, we have our box with our two-dimensional view of a cylinder. And after generating that, our geometry is all set. Now I'm just going to double click on Mesh to get that going. From here, I'm just going to go ahead and start by naming all of my edges. And I'm just going to click on my mesh. And we've generated just a basic one here. From here, we go ahead and go to sizing. So now that I have this set up, I'm going to go ahead and add an inflation. And you can see our layers now. With that, I'm going to go ahead and close out my meshing and update it here on the workbench. Once we have our green check mark, we can go over here to setup. I'm going to change this to double precision and for solver processes. From here, I'm just going to double check and make sure that my type is a pressure based with time set to steady. I'm going to go ahead and change this from viscous to laminar. I'm going to change my density to 1 and my viscosity to 2. After I've done that, I'm just going to double check and make sure that my material is set to air. And then I'm going to take a look at my boundary conditions. Now, to get the Reynolds number less than 1 in this case, I'm going to be setting my velocity to 1.5. When I set my velocity to 1.5, I'm going to get a Reynolds number of about 0.75. So we know that's less than 1. I'm going to hit apply and close. I'm going to double check and make sure that my reference values are being computed from the inlet. My density is 1, my velocity is 1.5, and my viscosity is 2. Those are all things that I set them to. From here, I'm going to go over to initialization, change my number of iterations to something a bit higher. For that, I'm going to do a set of 250 iterations for my calculation. And then I'm going to go ahead and run it. Real quick, I just wanted to come back because I realized I forgot to show how I added my reports for drag and drag coefficient. So if you go over here to report definitions and double click it, I'm just going to go ahead and delete them and act as if they weren't there because I added them after going through my report. So if we were running it just like normal, we would double click report definitions, there would be none, so we would click new, force report, drag, and I just started with the drag coefficient first because that's in the order that it is, so it's a little bit easier for me to remember. The zone is going to be the cylinder wall, and then I'm just going to click OK. And then same thing for the drag force. I'm just going to click OK, and then we have our 2 reports up here. And then if we wanted to see those, we'd come down here. And it's currently showing unavailable because I haven't run it. So I'm going to run it real quick. And you can see it was running with those reports in addition to the residuals. Now, if I wanted to check those reports, I would double click reports, go down here to forces, this, and print it. And then we have it all printed here. And then you can move on and continue your evaluation. That is how you add on those values to get for the report. Once that's complete, I'm going to go back to my workbench and I'm going to double click on results. Once I have this pulled up, I'm just going to go ahead and start by making my contours. And I always set my number of contours to 110 just because it's easiest to set it to that. And then one of the first things that I do as well with my first contour is I go over here to Legend and I just make it look a little bit nicer. So now that we have that all cleaned up, we can see our pressure contour here. I'm going to go ahead and unclick it and create the velocity contour. Here's my velocity contour. So next I'm going to go ahead and do my velocity vector contour. I'm going to do 50,000 for my number of points. And if you zoom in, we can see our vectors. Finally, I'm just going to go ahead and add my streamline so that I can compare it to the handout that we were given. I'm going to start from the inlet. And I'm going to do 1,000 number points. And then you can always increase this and decrease this. The more points you do, the longer it does take to show them to you. But this is what we're looking at with 1,000. If we bump that up to 10,000. We get a few more lines in there. And then if we compare this to the handout, we can see that for case 1, it's almost spot on there. So that concludes case 1 for project 3. Next up, I'll be doing case 2. So now that we're back to our workbench, the great thing about Fluent is that we can easily go to the little drop-down menu here and duplicate a specific system. That way we don't have to worry about redoing our geometry or redoing our mesh if we know that what we had previously works. So I'm just going to duplicate the case that we just did for Reynolds less than 1. I'm going to go ahead and rename it though. Case B is going to be where Reynolds number is equal to 40. So we still have the green check mark for our geometry, our mesh. We also have it for setup, but we're going to go ahead and double click that because we're going to change our values to make sure that that Reynolds number is equal to 40. So we're going to go ahead and keep it double precision with our processes set to 4. Now, once it's started up, it's going to have all those same values from the last time. So in the technicalities, you could just go through and only change the things that you want to change. But I'm going to go through and just double check everything and make sure it's exactly the way I want it before running it. So we can see here, it's still set to laminar. That's what we want. Now I am going to go ahead and change my viscosity here to 1 instead of 2. I'm going to double check and make sure that it's still showing air as my material. And I'm going to go ahead and change my velocity to 40 meters a second. That's how we're going to get our Reynolds number to be 40. From there, my initialization is still set to 25. So I'm going to go ahead and initialize. And then I'm going to go ahead and run my calculation with 250 iterations. Once that calculation is complete, we can come back here. We've got the green check mark on our setup, so we can double click results. Now it does already have all of the same contours because we duplicated it, but it's important to know what we're looking at. So I'm just going to go ahead and unclick velocity contour. It looks like my pressure contour, my streamline, and my vectors did not carry over. So I'm going to go ahead and make those. So here we have our pressure contour. I'm going to go ahead and do my velocity vectors. Spare myself, I'm going to do 50,000, I believe is what I did last time. That looks much better. If we zoom in here, you can actually start to see our fluid flow back. I'm going to increase this to 100,000 so that we can see this a bit more defined. So now if we compare this to the handout, you can actually see that recirculating wake, just like we have here. And our flow separation about right here, similar to that in the picture. So from there, the only thing left to do is our streamline. I'm just jumping back in here because the first case, when I did my streamline, I calculated it from the inlet. And as I was messing around with the project, I found that it was actually better to calculate it from the body itself. So I'm just coming back to show you how to do that, or how I did it. So as you can see, we don't have our streamline here. I'm going to go right up here. And then instead of starting from the inlet, we're going to do symmetry 1. And I'm going to start with, we'll do 1,500 points and apply. It's not quite as many as I'd like, so I'm going to bump that up. And that's looking a lot better. So the difference between calculating from the inlet and the streamline, if I change this to inlet, we're not getting any of that turbulence inside the wake. So in order to see that, we have to do it from symmetry 1. And from here, it's easier to see how similar it is to the handout with those two symmetrical turbulences in the wake. So next up, we have case 3. We're going to do the same thing. We're going to go ahead and we're going to duplicate. Once we have that duplicated, I'm going to rename mine. Case 3 is going to be a Reynolds number greater than 100, but less than 200. So we're going to do the same thing. We don't need to worry about our geometry or mesh. We're going to go straight into our setup. Double precision for solver processes. All right, so starting off for case 3, we can see that it's pressure-based and a steady time. We are good to go there. We are still a laminar model. I'm going to go ahead and update my viscosity. I'm going to change it from 2 to 1 times 10 to the negative 1. And density, I'm just going to keep it 1 for this case. Now I'm going to go ahead and update my velocity to 15 meters per second. And if we give 15 meters per second with that viscosity change to 0.1, I'm going to get a Reynolds number of 150, which is right in between 100 and 200. From there, just going to go ahead and initialize with my 25 iterations. And actually, before I run the calculation, I'm just going to double check my reference values, make sure that this is coming from the inlet, and that everything carried over, which it did. I'm going to reinitialize. And now I'm going to run my calculation. So from here, we can go over to results. It looks like it did the same thing as last time. It carried over the velocity contour, but not the pressure contour. So I'm going to go ahead and add that. Now, if we really zoom in, you can see that the wake is recirculating right around here and here. Let me go ahead and compare that to what it's supposed to look like. So if we're just looking at this and comparing it to what we're supposed to get an alternating vortex formation. And although they're backwards, we are getting that alternating formation. If you look, the line of symmetry is going to be right in here, as opposed to right here on this one. And we've got that recirculating wake here and here. From here, the only thing left to do is go ahead and do my streamline. And there we have it for case 3. I'm just doing the same thing that I did for the last case. I am redoing my streamline to show it also being calculated from the cylinder itself. So as you can see here, I don't have my streamline here, so I'm going to go ahead and add that. We're going to start from symmetry 1. And we're going to do 14,500 points. When we apply that, you can see that we have much more turbulence here in the wake region than we did on the previous streamline. And it's also a little bit easier just to see those two alternating vortexes here. So now back to our workbench for case number 4. We're going to do the same thing we have been. We're just going to duplicate our first system. And I'm just going to rename this. In this case, we are looking at a Reynolds number that is greater than 400, but less than 3 times 10 to the power of 5. Oops. Our geometry and mesh are good to go, so I'm just going to double click setup, double precision for solver processes. Now that it's pulled up, we can see that we're still pressure-based steady. We've got our laminar. Now in this case, I am going to change my viscosity to the -3. And then for my inlet velocity, I'm going to change that to a value of 100 meters per second. And with keeping our density the same and our diameter, we're looking at a value of about 50,000 for our Reynolds number, which is definitely less than that 300,000, but greater than 400. With that, I'm just going to double check and make sure that we're computing from the inlet and that all of my values carried over. Now that we have that taken care of, I'm going to go ahead and initialize with my 25 iterations and run the calculation. Once my calculation is complete, I'm going to head back to the workbench and double click on results. And it's done the same thing it has the last couple of times where it didn't carry over the pressure, contour, or the vectors or streamline. So I'm just going to go ahead and do that real quick and then come back once they're done, and then we'll go through them. Okay, so now I've added my pressure contour. We can see that right here. You can get a close-up of the velocity contour for this case. You can definitely tell that it's a turbulent wake region just from how jaggedy this area is on our diagram. We can also take a look at the vectors and see how they're going just any kind of which way in the wake region. And if we compare that to the project handout, then we can see that they're just going any which way, and that's because it's that turbulent wake region. Now, if you're looking at the laminar separation, it's about a little less than halfway on the diameter of the cylinder, and it's the same over here. You can see these first vectors shoot off right about here, and that's where that flow is separating from laminar to turbulent. Then we can also take a look at our streamline. It looks like it could be smooth, but if you actually add a bit more points, see that it starts to curl back in on itself. And once again, I've just come back to case number 4 to redo the streamline to show the difference that it makes. So I'm going to go up here and add my streamline in. And instead of doing the inlet, we're going to do symmetry 1. And we're going to do 14,500 points. And with that, you can see all of that turbulent flow coming back in the wake region that you couldn't see if you're calculating your streamline from the inlet. So you can start to see it just come back towards our cylinder. But from there, that is our case 4. Next up, we will be doing our final case, case 5 of that very, very turbulent Reynolds number greater than 300,000. Okay, and now we are back on our workbench for the 5th and final case. I'm just going to go ahead and duplicate our first system. From here, I'm going to rename it. In this case, we are looking for a Reynolds number that is greater than 3 times 10 to the 5th power. I'm going to double click setup. Double precision with 4 solver processes. So once we have this pulled up, we're just going to double check we are pressure-based and steady. Everything should have carried over. As we can see here, our model is still viscous laminar. For our fluid in this case, I'm going to keep my density at 1 and my viscosity I'm going to change to 1 times 10 to the -5th. From here, I'm going to change my velocity. In this case, I'm going to change it to 5. And with those values, when you calculate out your Reynolds number, you're going to get a value of 500,000, which is indeed greater than that 300,000 we were given in the handout. We're going to double check our reference values and make sure we're computing from the inlet. My density is carried over, my length is carried over, my viscosity is carried over, and my velocity. So we are good to go there. Next things next, I'm going to go ahead and initialize with my 25 iterations. And then from here, I'm going to run my calculation. Once our calculation is complete, we're good to move on to the next step. Since I didn't show it in the last couple of them, but I did show it in the first one, I'm just going to refresh on how to double check your drag coefficient and your drag force. Because we duplicated from the first one, we have our reports all set up here. I'm just going to double click the first one, hit compute, and OK. And as you can see here, we have our drag force that was calculated. We're going to do the same thing here. Compute, OK. And now we have our drag coefficient. From here, we're going to go back to our workbench. I'm going to go ahead and update my results. That way it carries over the data that it just calculated. And now that I have the green check mark, I'm just going to double click and open that. So it looks like we have our streamline and our velocity contour, but not our pressure contour or our vectors. So I'm going to go ahead and add those real quick. Okay, so now that I have those added, we can see this is what our pressure contour looks like. We've got our velocity contour. You can see that kind of turbulent wake region right in here. And then when we look at our streamline and compare it to what was given in the handout, we can see that we have that narrow region here for the wake. And our turbulent separation is going to be happening right around these two areas right here. And then we've got that really turbulent flow right in here. From there, we just go and we pull our drag coefficient and our drag force to add to the report. But that is all 5 cases that are in the handout. Thank you so much for watching and have a great day.